Find explicit formulas for sequences of the form A1, A2, A3, and so on with the initial terms given in 10 through 16. So here's the sequence. In order to identify the explicit formula for this sequence, we have to establish a relationship with the index variable and the terms of the sequence. What do I mean by the index variable? Well, this first term here is a sub 1. This subscript here is called the index. And for the purposes of this problem, we'll say that the index variable is n. And so the first term corresponds to when n equals 1. The second term corresponds to n equals 2. The third term corresponds to when n equals 3, and so on. And we need to establish a relationship between this index variable and the corresponding terms of the sequence. And you can see there's kind of a pattern here. The first thing I notice is that the denominator of the first fraction happens to be the same as whatever the value of the index variable is. But that's with exception to the first term. And so what might be useful here is to consider this first term, instead of 1, we should consider it as a fraction. 1 is a fraction. It's the same thing as 1 over 1 or 2 over 2 or 3 over 3 or 4 over 4 and so on. But which fraction should we consider here? Well, if this is 1 over 3 and this is 1 over 2, then we can imagine this should be 1 over 1. And now we can more easily identify a relationship between the index variable and the actual term. The formula I notice is that whatever n is, the corresponding term will be 1 over n minus 1 over something. Now, the denominator of the second fraction is always going to be 1 greater than the denominator of the first fraction. And if the denominator of the first fraction is whatever the index variable is, then the denominator of the second fraction is going to be 1 greater than the value of that index variable. And so this is the explicit formula for this sequence. Let's test to see if this formula works by plugging in 6 for n. If we plug in 6 for n, we should get 1/6 minus 1/7. But let's plug in 6 into the formula, and we get 1/6 minus 1 over 6 plus 1, which is 7. And that's what we want. Thanks, everyone, and I'll see you in the next video.